So we are now to the all-important properties of logarithms section, which is section 7.5, page 507. Okay, the other day we talked about our two minor properties of logarithms. These are now going to be the main major properties of logarithms, and there are three of them. So, you want to make sure that you guys memorize these things letter for letter. Okay, it's going to be very, very important. Okay, the first one is called the product property. Product means what? Multiplication. The product property says that if you have log base b of some number m times some number n, notice that product is inside the logarithm, taking the log of both m times n. That can be broken apart into two separate logarithms, log base b of the first one plus log base b of the second one. This, going from left to right, is called expanding. And that's all we're going to deal with today. We're going to talk about the other direction tomorrow. I'm going to do this a little differently than I've done in the past. So we're just going to focus on expanding today, going from left to right. Now, these properties are very important, and you do need to memorize them with the b's and the m's and the n's so that you know exactly what this thing says. But it's not enough to know what it says. You guys also have to actually use what it says. The properties of logarithms are very, very specific, guys. They do one thing going forward, they do one thing going backwards, and if the property does not specifically say that you can do something, then you cannot do it. And if you try and make it do it, it's going to give you the wrong answer 100% of the time. End of story. You've got to know exactly what it says, because far too often people don't really memorize what it says or pay attention to what it says. And all they remember is the basic gist of it. Oh, multiplication, addition, 1 log, 2 logs. And so what they end up doing is they make up properties on their own that kind of sort of remind them of the actual property. The only problem is the actual one works every time, and the ones you make up that kind of remind you of the actual property never, ever, ever work. They always get you the wrong answer. Okay? So, if you guys are not going to spend the couple minutes it takes to actually memorize these properties, then I have a recommendation for you. You guys should go out and invest in a really nice hat, because you're going to be wearing it for a while to cover up the bald spots from you ripping your hair out by the fistful out of frustration. Because you're going to do every single problem wrong if you don't learn these properties. And you guys smile and laugh, you think I'm joking, but seriously, go get a hat. One that you're going to be comfortable wearing for the next month as your hair grows back, all right? So, what does this say we can do? For example, this tells us that if we have something like log base 2 of xy, that can be written as log base 2 of x plus log base 2 of y. That's expanding. Okay? If we have something like log base 5 of 2x, that would be log base 5 of what? Not base 2 of x, base 5 of x, right? There you go. That's it. That's all it does. Now, let me ask you this, guys. I said that you can only do what it says that you can do, nothing else. What if this was log base 5 of 2xy? Could we use this property? Actually, you can, but you've got to just tweak the way you think about it. This says I can take the log of two numbers being multiplied. Can I think of this as two numbers being multiplied? Yeah, couldn't I think of this as being my m? Right? Isn't 2 times x one single number? we don't know what that number is because we don't know what x is, but isn't 2 times something one answer? So you could think of the 2x as your m, and you could think of the y as your n. And so what would this break into? Log base 5 of 2x plus log base 5 of y. Now, would we be done expanding this? No, what do you think we can still do now? Now, you can break this apart to where the 2 is your m and the x is your n. So what would this break apart into? Keep going. There you go. And so do you see that we can actually stretch this by using it one step at a time, and we can use it multiple times in a row? Now, technically, would you have to show this in-between step, or could you go straight from here to here? You could go straight from the beginning to the end if you want. It's safer to go through the middle, especially when we get to the subtraction one, though. Okay? But technically, on the addition one, you could go from step 1 to step 3. Okay, questions about the product property? Let me show you what the product property does not say. And so I want you guys to put this in your notes. I'm going to put it in red, because those of you that don't study the properties and don't pay attention to the properties are going to make these exact mistakes on the test. These are the danger mistakes. So let's say I don't study this property. I just remember, oh, 1 log, 2 logs, multiplication, addition. So that must mean that log base b of m plus n becomes log base b of m times log base b of n, right? 1 log becomes 2, addition changes to multiplication. Isn't that what the property says? No, that's why this is one of the danger things, guys. Look at what we started with. Does this match the structure of this? No. If it doesn't match the structure of that, you can't use it. It's that simple. If you try and force it to work, you're going to end up with the wrong answer 100% of the time. Now, we didn't force it to work on that last example. We just changed the way we thought about our m and our n, right? We lumped a couple things together to get our m. That's different. But if I try and force this to work, I'm going to end up with the wrong answer. Another thing that people constantly do on this one is they get log base b of m plus n, and it has nothing really to do with the property, but a lot of times people try and say, sorry, this should be not equal to. Try and distribute this and make it log base b of m plus log base b of n. Guys, this stuff is inside of our logarithm. It's not log base b times that stuff, so there's nothing to distribute. Okay? Log base b is an operation. Okay? It's not a number. Log base b of something is a number, but log base b by itself is an operation. That's like having an empty square root. Could you distribute a square root? No, you distribute numbers, right? This has no meaning other than in your calculator where you're saying that this goes inside of that, but that's just because of how your calculator prints things. You can't multiply this thing in because this is not a number, right? You could take a 2 and you could multiply it in. That's different. That's okay. But log base b without a number in it is not a number that can be distributed. So this does not distribute. Okay, so do not make these common mistakes, okay? Questions about the product property? So 1 log with multiplication inside becomes 2 logs with addition between them. That's all it does going forward. And we'll talk about what it does going backwards tomorrow. Because properties, if you remember from geometry, properties go forward and backward. We're only dealing with the forward direction today. Okay, questions on the product property? Okay, the next one is called the quotient property. And the quotient property says if you have log base b of m divided by n, this becomes 2 logarithms with subtraction in between. So for example, log base b of 5 over x becomes log base b of 5 minus log base b of x. What if, well, it's okay. Questions about that? That's what it does. Same thing as the product one, except that it's with a minus in between. So 1 log with division becomes 2 logs with subtraction. Again, going this direction is expanding. Going backwards, we call it condensing. We'll deal with that tomorrow. Now, what do you have to watch out for? And I want you guys to study these danger ones, because I'm telling you all right now exactly the mistakes that those of you that bomb the test are going to make. So if you study what not to do, you guys should be fine. Okay, so what is one of the danger ones? One of the danger ones is people, again, they don't memorize the property. They just go, oh, I know division and subtraction go together. And 1 log and 2 logs. So that must mean that log base b of m minus n becomes log base b of m divided by log base b of n, right? 1 log becomes 2, subtraction turns into division. Isn't that what this says? No. Does this match the left side of the original? No. So you can't use this property to do that, because they don't match. It's subtraction instead of division. It's not the same. If you try and make it work, it's going to give you the wrong answer. Again, log base b of m minus n, log base b is not a number, so you cannot make it into log base b of m minus log base b of n. Okay, you cannot distribute. So be very, very careful with that. Don't do either of those two things. Okay, questions about that? Do you guys see how simple these properties are? They don't do much. They do one thing going forward. They do one thing going backwards. Now, the other thing I want you to notice on both of these properties is there a letter holding the place of coefficients? Actually, that's really condensing. We'll deal with that tomorrow. Never mind. Let's not worry about that today. We'll deal with that tomorrow. Okay, so forget I mentioned that. We'll come back to that tomorrow. Okay, the third property is called the power property. The power property says that if you have log base b of, they use m and n again, of m raised to the nth power. Notice, what's being raised to the nth power? Just the m, not the whole logarithm. Okay? This says that you can take this exponent and you can bring it down in front and make it a coefficient. This becomes n times log base b of m. Notice the whole thing inside the logarithm is being raised to the power, but the logarithm itself is not being raised to the power. Everybody got that? So for example, log base 3 of x squared is equal to 2 times log base 3 of x. This gets to move down there and become a coefficient. Which is really nice, guys, because if I have something like log base 5 of 7 to the x power, we're going to have to solve equations that have stuff like this in it. We're going to be solving for x. The problem is x is an exponent. We don't have any algebra tools for solving when x is an exponent. We can do x raised to different powers, but not when x is a power of its own. This property allows us to take this x and drag it down to the front, and now x is no longer an exponent. And so you get x times log base 507. Does everybody see how that works? Now let me show you the danger ones for this particular property. Log base 3 of xy squared is equal to 2 times log base 3 of xy. These are not equal to each other. Why not? Well, does this match the structure of that? No, why not? It's not the xy itself, because couldn't we just think of this whole thing as m? We're just squaring the y. Notice the property, guys, says that whatever you're taking the log of, that whole thing has to get raised to the power. Is this whole thing being raised to the power? No, only the y is being raised to the power. So since the whole thing is not being raised to the power, we can't move that exponent out to the front, because if I move it out to the front, now it's affecting the x and the y. That's not correct. That's not what the original said. What would be the right way to do this? Let me change back to black, because now it's the correct way. Would be to break this up using the product property. Since these two things are being multiplied, you can look at this as your m and this is your n. What would this thing break up into? Your m and your n from your product property, the first one we learned. Y squared. That's acceptable, isn't it? And now could we use the power property here? Yes. Now this guy can move to the front, and so the correct answer would be log base 3 of x plus 2 log base 3 of y. Now the 2 only affects the y, just as it was in the original. So the red one is what not to do. The black ones are what you should do on this problem. Now those other ones, the red ones, there was nothing to do on those. We don't have a property that will let us do anything on those other red ones. So this is the proper usage of the power property. Questions about that? Okay. Now, I want to mention something to you. The first property that we learned, the first minor duh property, was if you had log base b of b to the p power, the answer was just p. And then we had b raised to the log base b of p was equal to just p. On a scale of 1 to 10 in terms of usefulness, I'll give these each, 1 to 5 stars in usefulness, I'll give these each 1 star. Then we had our product property. Log base b of mn equals log base b of m plus log base b of n. And so on a scale of 1 to 10 or 1 to 5 stars, I would give this about 3 stars in terms of usefulness. Same thing with the quotient property. Log base b of m minus log base b of n. I would give this 3 stars on a scale of 1 to 5 stars for usefulness. These are much more useful than these, although we do use these from time to time. The power property, however, on a scale of 1 to 5 stars, yeah, go big or go home, right? Get the idea? Yeah. Yes, absolutely. This property, guys, is really the whole reason we care about logarithms. If this property did not exist, we really wouldn't care about logarithms. Because this is the one that allows us to take an exponent that is a variable and make it so that the variable is no longer an exponent. And then, once we bring it down to the main part of the equation, so it's no longer an exponent, then we can use all the algebra tools we've been learning our whole lives. Okay, so this is really where the power of logarithms lies, is in the power property. All right, questions about that? Okay, let's take a look at a couple of expansion problems, because that's what you're going to have tonight. So they're going to ask you to expand, which means expand fully. So you can't expand anymore. So you might get something like log base 2 of 5xy cubed. Well, can I pull the 3 out to the front? No, because the whole thing is not raised to the third power. What can I use on this to begin with? Product property. So if I group these two together, what does this break up into? Good, log base 2 of y cubed. Now, can I do anything with this? Product property again, right? What does it become? Can I do anything with this? Yes, bring the 3 down to the front, and it becomes plus 3 log base 2 of y. Now none of my properties apply anymore. That's the final answer. That is fully expanded. Do you guys see how easy that is? Now let's make things a little more complicated. Log base 2 of 5x over 3y cubed. What do you think we should use first here? Quotient property. Good. Get rid of this division part first. So this is your m, this is your n. So what is this going to become?
Log base 2 of 5 minus log base 2 of 3y cubed.
Good. Now what can I do with this stuff? Product. So what does it become? Okay. And then what does this become? Now, everybody okay with that? You shouldn't be, because we now have the wrong answer. The problem is this. No, we're not done yet, but it's already wrong. And here's why. Notice, guys, that this entire thing had a negative attached to the front of it. But notice when we broke it apart, the whole thing doesn't have the negative attached to it, only this first logarithm does. So what must we have here? Parentheses. You either need to put parentheses here, or you need to change that plus to a minus. My recommendation, start out by putting a parentheses there. Whenever you break something apart that either has a negative in front of it or a number in front of it, a coefficient, make sure when you break it apart you put parentheses around it, so whatever was attached to the front is still attached to the whole thing. Now we can make this into log base 2 of 5 plus log base 2 of x minus parentheses log base 2 of 3. What does this now become? 3 log base 2 of y. Now, would we be done here? Actually, you could be. You could leave your answer like this, or if you want, you could distribute the negative and get log base 2 of 5 plus log base 2 of x minus log base 2 of 3 minus 3 log base 2 of y. Does it make sense why those both have to be minus, guys? That's what puts them both back on the bottom if we were to go backwards. Does everybody see how that works? So be very careful. Whenever you split something apart that has something attached to the front of it, you've got to make sure you put parentheses around it when you break it up, so it's still attached to the whole thing. Okay, one more that I want to show you, but are there any questions on that one? Okay, the other one I want to show you is what happens if I have this. Three square root of x, log base 5 of 3 radical x. Well, first we can use our product property, right? Everybody with me on that? Now, there's a problem, guys. We are not done expanding this yet. Okay? But we don't have a property that allows us to do anything with that square root of x part. But what we can do is we can rewrite this as what? X to what power is the square root of x? 1/2. So we do not have a root, square root, cube root, any kind of root or radical property of logarithms, but we do have a power property. So whenever you see square roots and cube roots and the like, you need to change them into exponents. Now what can I do with that 1/2? Power property, right? Move it to the front, and so the final answer would be log base 5 of 3 plus 1/2 log base 5 of x. Everybody see how that works? That's what you do with roots. What if that was a cube root instead? What would the power have been? 1/3 power, right? Okay, questions about that? Okay, the homework, just so you can get some practice with these.